harsh environments and are durable against extreme temperatures, vibration, and moisture. And shown here is a Molex connector on a Cybertruck. Image source, Molex. NA with more innovation opportunities in vehicle design, more vehicle manufacturers are embracing electrification practices, as said Luke. Because of the hyperfast innovation cycle, there are few standard platforms in the space. However, the increased variety offers consumers more options, and we expect the cost of vehicles will likely decrease as technology advances and production ramps up. And considering commercial vehicles and while much has been said about passenger cars. Everything discussed in this article has been going on much longer in the commercial vehicle, CV, space. Commercial vehicles quickly transitioned from 12V to 24V systems to power diesel and some electrical systems, which allowed them to have smaller starters in the past. There is also a long history of electric vac in CVS, especially in buses, construction, and agriculture vehicles and heavy-duty trucking, among others. And commercial vehicles are typically designed to help their owner or operator make money and, therefore, must work reliably. The pressure for a CV to perform reliably is typically higher than that of passenger cars, so extra sealing and robustness are needed. And whether designing for passenger or commercial vehicles, engineers today must consider numerous complex, power-hungry systems and features that not only meet consumer and commercial demand but are also highly efficient, durable, and safe. Content, Air, Automotive navigating the automotive electrification movement. And Matt McWhinney and Kirk Ullery of Molex and Sean Luke of DigiKey share insights on the past, present and future state of vehicle electrification. Whether designing for passenger or commercial vehicles, engineers today must consider numerous complex, power-hungry systems and features that meet demand and are highly efficient, durable, and safe. Image source, Getty Images. And their automotive industry's evolution through electrification, replacing traditional mechanically driven systems with electric components and systems, is profoundly changing the design of today's vehicles, which range widely from internal combustion engines to mild hybrids to fully electric architectures. And our systems have evolved from carburetors and simple exhaust systems to precision fuel injectors, emission systems, and traction and braking control systems. Similar advancements have been made in electrification with new architectures, components for electric motors, battery packs, and advanced power electronics. Combined, these advancements are pushing engineers to reimagine how vehicles are designed and driven for maximum efficiency, reliability, and safety. And experts from two industry-leading electronics companies, Matt McWhinney and Kirk Ullery, business development managers at Molex and Sean Luke, technical marketing manager at DigiKey, shed light on the current state of the electrification movement and key considerations for the future of the automotive industry. And vehicle model landscape. And while the highly watched demand for electric vehicles, EVs, and hybrid vehicles continues to increase, sales of new EVs have slowed over the last several months due to many factors, including market and public policy. Industry experts cite cost and the limited charging infrastructure in the US as two major reasons. We've had fits and starts on electrification in North America, Ullery said. If you're going more than 100 miles at a time, you know charging infrastructure needs to be addressed. And hybrid vehicles, on the other hand, are outpacing EV sales. According to Edmunds data, hybrid purchases in the US saw their biggest surge in 2023, increasing from more than 750,000 sales in 2022 to tipping over 1 million sales in 2023. And another emerging category is the mild hybrid, which uses a battery-powered electric motor to supplement gas or diesel usage. Most mild hybrids run on a 48V electrical system, which is a higher voltage than the electrical systems of a traditional combustion engine vehicle. The 48V system powers components that are not reliant on the engine, enabling better operational efficiency. And even with the fast pace of innovation in automotive design, gas-powered vehicles still rule the roadways. According to research by Edmunds, 82% of new vehicles sold today in the US rely on gas. However, the electrification movement is well underway among traditional vehicles to the most advanced high-tech electric models. And electrifying under the hood. And one constant we're seeing is a lot more electrification. Mechanical systems are becoming electrified in all vehicles for many reasons, especially to drive efficiency. A Ullery noted. One example is stop-start technology, which turns off the engine when a vehicle stops and automatically restarts when the driver releases the brake or pushes the gas pedal. While this feature can put extra demand on some components, it aims to improve fuel efficiency and reduce greenhouse gas emissions. And other examples of electrification under the hood are in radiator fans, power steering, vac systems, and cooling pumps. All these systems used to be powered by belts of an internal combustion engine, ICE. Electric water pumps are replacing mechanical radiator pumps for more efficient performance, and the precise control with electrical cooling can extend the lifespan of these parts. If there is extended battery management, they also circulate coolant throughout a vehicle to regulate the temperature of the battery pack, electric motors, and power electronics. And switching to electric-powered modules such as power steering pumps makes the system no longer reliant on the engine, reducing parasitic loads and allowing for more available horsepower. Therefore, automakers can install smaller engines in some vehicles and retain the same driving performance while gaining efficiency benefits and outputting lower emissions. And electrification has opened the door to innovative new vehicle designs, as said Luke. Without the need to accommodate the belt-driven architecture with a traditional internal combustion engine, auto manufacturers have more flexibility in where to distribute batteries and charging ports, the ability to increase the amount of space for passengers or cargo, and more. And overall, the electrification movement is replacing traditional mechanical with precision electrically controlled systems that can be more efficient. Combined with advancements in software control, modern vehicles are cleaner, more energy efficient, and offer performance and sustainability for both passenger and commercial drivers. And vehicle battery advancement. And over the last decade, vehicle manufacturers have switched from 12V to higher voltages, such as 24V, especially for commercial vehicles, and now to 48V batteries to increase power capability, reduce vehicle weight, improve acceleration, and realize fuel savings. And legislation in the US and Europe has been laying the groundwork for emissions reduction in newly built vehicles. A combination of regulatory and market forces is behind the increasing shift to mild hybrid architectures, which include integrated starter generators. 48V is not only growing in mild hybrids, but also seems likely to emerge in more ICE platforms. And the shift to 48V architecture involves more than just increasing system voltage. It also requires a change in the electrical foundation. Feature-rich, high-performance vehicles rely on lighter and smaller components that deliver the same electrical efficiency as a higher-density model. And the common thing is that both 12V and 48V systems are moving traditional mechanical functions of a serpentine belt to a series of electric motors, said Ullery. He shared an example of a heavy-duty pickup truck using mechanical energy for its power steering. In many vehicles, this function is becoming electrified. The amount of energy needed for the power steering takes away from the engine's horsepower, so by moving it to a separate electrical system, drivers can maintain more power through the drivetrain. And their automotive industry's move to higher voltage systems is a gradual one, given the significant impact on the design and manufacturing process. Each manufacturer's transition is on a different timeline based on their products, technical maturity, and the requirements of the customers they serve. Plus, all are held to standards and design practices related to the technologies they will be using, including /N/, ISO 21780 covers requirements and tests for the electric and electronic components in road vehicles equipped with an electrical system operating at a nominal voltage of 48 V. /N/, and the VDA recommendation 320 is published and maintained by the ZVI German Electrical and Electronic Manufacturers Association. It covers a wide range of specifications and test requirements for electric and electronic components in motor vehicles to develop the 48 V power supply. /N/, and following the standard to achieve smart battery management is integral to the success of 48 V architecture. With the right design process, automakers can avoid inefficient power storage, increased costs, and potential safety risks to drivers. /N/, and interconnection fundamentals to prioritize safety. /N/, and with vehicles requiring more power than ever to support increasingly sophisticated electrical features. A reliable connector design for 48 V systems relies on several fundamental factors to meet vehicle performance and safety standards. /N/, having electronics and the infrastructure, the interconnects to support your vehicle, is essential for safety. Said McWhinney. /N/, and since 48 V systems operate at a higher voltage than 12 V, connectors and electrical systems must be built with robust materials and proper insulation for safe, reliable performance. This becomes even more important if the voltage is higher than 48 V. /N/, and connector failures can cause vehicle system malfunctions or safety hazards. To prevent disconnections,